Hi, welcome to our fourth lecture. This one is on a new kind of Java statement called conditional statements, usually known as if statements or if-then-else statements. So the goals of this video are to see the syntax of the if statement, which is a little more complicated statement than the ones we've been using so far, to understand one of the major components of the if statement, which is something called a boolean expression, and to look at more complicated if statements and common pitfalls and mistakes people make with if statements. So far, we've written a few programs, and sort of once you see what it does, it keeps doing the same thing, right? You run it and it says hello, and even your homework assignment, you have to go in and modify the program to get different behavior. In other words, change the numbers that you're using in your calculations. So we would like somehow our program to start making decisions based on the data that's available. And the way we're going to do that is with a new statement called if-then-else, kind of like just an if statement. So this allows for conditional execution of statements. So what does that mean? It means there's some condition, some check that decides whether one statement is executed or another one. Now, the basic if statement has a structure that looks like this. Let me get some. So it's if, and then inside parentheses is something called a boolean expression. And I'll talk quite a bit about a boolean expression, but basically it's something that evaluates to true or false. And if that's true, there is a statement that is true that is executed. Otherwise, or else, if the boolean expression were false, then this statement executes. So either this one executes or this one executes, and this one for true and this one for false. So there's some kind of decision being made here. I want to point out that here the indenting is important for humans to understand what's going on, but Java doesn't care about the white space or indenting. Some of you may take that as sort of leave to do whatever you want with indenting, but no, it's very important to keep it consistent for us to understand what's happening. So we'll look at that indenting issue a little bit more as we go along here. All right. That Boolean expression in some ways is the heart of the if statement, and it's a little bit hard for us to feel comfortable with that. We actually use them all the time in our own statements. In English, for example, we might say, I have completed assignment 1. That statement evaluates to either true or false, and really strictly true or false. Now the problem is in English, when I say I have completed assignment 1, we're sort of used to there being a little bit of uncertainty to it, or wiggle room, or like I've mostly completed it, but I'm going to call it done, or I've completed it except for, submitting it or something like that. So anyway, there's in English, it's sort of this understanding that it's not 100% true or false. In the computer use of Boolean expressions, it is only true or false, not 90% true or anything like that. So we have to kind of move from this a little bit sloppy or vague form of making these kind of statements to very precise ones. So just keep that in mind, that this is something that evaluates to true or false. In Java, there's a type, Boolean, lowercase b Boolean, because it's a primitive type, so it's lowercase, and it holds these true or false values. So I guess let's go over, I lost my cursor somewhere, okay. Let's just go over here and make one of these. So get a little space there. Okay, so we're used to something like int number equals 3, and the yellow line there is showing that I'm not using that variable. So Java Eclipse is right now wondering why I bothered making it, but we're just making it for an example. So again, there's the type, there's the name of the variable, and then there's the initialization to 3. For a Boolean, again, this is going to be something it's like a status, right? Like I've finished something, or the game is still going. So here I use the game over, and I can assign it false to start off, and the value that it holds is false, right? The only two things it can hold are these lowercase true or false. So these are keywords in Java. They're not text, they're not a variable name, they're not, a string with quotes around it. It's just literal, kind of like a number. Now, can I hold something else in there? 10. It says here, type mismatch, cannot convert from an int, 10, to a boolean, game over. So you're not allowed to do that. The only two things you can hold in a boolean are true or false. And again, that seems very restrictive, but these are very important types of variables, and they're used in these boolean expressions, and they get a lot of use in programming. So just think of it as like a very small alphabet of something we can hold, or like if we had numbers that only hold 0 and 1, a boolean would sort of be equivalent to that, where it holds two different types of values. But anyway, we have to get used to this sort of very restrictive kind of data type. So we're going to talk about the semantics a little bit, right? So if that boolean evaluates to true, here I just wrote true directly, right? That is an expression, a boolean expression, true. What does it evaluate to? It evaluates to true. Here I wrote literal false. That's a boolean expression. What does it evaluate to? It evaluates to false. But so if this statement here is true, this boolean expression, then it executes that first statement after the if, right? There's no semicolon here. It's just the statement immediately following that if boolean expression. If it's false, it jumps over that and finds the statement by the else and executes that instead. Notice when it's done with a true statement, like if it were true, it executes this, skips the else, and then does whatever statements follow. Right? So it will either execute this one or execute this one, but not both. So it takes a little practice to kind of understand the flow of execution of this statement. So one question is, how do we make these Boolean expressions? Right now the only thing we know is true and false. So there's something called relational operators that examine the relationship between two values, and you can compare things. So for example, let's try something out over here. Let's do a system out print line. It's always really good just to experiment and see if you can, examine what's going on in a program. So when you print out a Boolean, it prints out the value inside. Just like if you printed out an int, it prints out the number. Here it prints out true. And again, that's not a string. By the time it gets to the console, it actually is a string, but here it's printing out true. So let's print out some other stuff. I'm going to print out number equal 3. Oops. This is a relational operator. It's the equality operator. And it sees if the number on the left and the number on the right, or the value on the left and the value on the right are the same. All right. So in this case, 3 is stored in number. So is 3 equal to 3? This is sort of an algebraic 3, where you're saying these two things are equal. And if I run this, it still prints out true because this expression evaluates to true. If I were to say, hey, is number equal to 4, then run it, it's false. All right. Now here's one thing that's a little bit hard for people to see and maybe like. So I could say here, if number equals 5, and print out here, game over. Let's make a little space here. All right, what is going on here? So again, we're going to run this program. Number equals 3, so we have this value is 3. Now I am creating a new variable, game over, of type Boolean, and I'm initializing it. And what am I initializing it to? There's really only two things I can initialize it to. It can be either true or false. So I have to evaluate this expression and decide what that value is. So this is saying, what is the value of number equal to 5? Well, number is 3. Is 3 equal to 5? No, it's not. So this whole thing evaluates to false, and I assign false to game over. People don't like this because there's like an equal sign here, and there's two equal signs here, and it all looks like a little, it doesn't look normal to us, right? We can't really, it takes practice to read that as a sentence. But this says, assign to this variable, the result of this expression. And so if I run this all now, it's false. All right, so the thing is, this number equal 5 is very similar. We're used to seeing things like this. For example, if I see 1 plus 6, I go, oh, what do I have to do here? I have to evaluate this expression. I recognize this as the plus operator, which means sum the number on the left operand, the right operand. These are all terms you may have learned even in elementary school. And we learned about adding and subtracting. We talk about operators and operands. Now, unfortunately, we probably haven't used them very much since then, so you've kind of fallen out of favor in your mind what that means. But that terminology hopefully is somewhere you can dredge up, right? And that's an expression. If I say number equals 3, it's the same thing. You recognize this as an equality operator. It works on the left operand and the right operand and compares them. And what it does is produces either a true or false value at the end. So that's just an expression. Do it kind of like math. Just evaluate it, and you get some kind of answer. All right. That's not the only relational operator. You can use greater than, less than, greater than or equal to, less than or equal to, and not equal. So, for example, over here, I could say, store in a game over the result of evaluating number not equal to 5. Is number not equal to 5? Is 3 not equal to 5? That is true, right? And again, you sort of have to force yourself to say it out loud or just work through it very carefully. But 3 not equal to 5 is true. And so we're storing true in game over, and when we print that out, we get the true. It's very easy to get yourself sort of confused. Oh, number's not equal to 5, so that's sort of false. Number and 5 are not the same, so that's going to be some sort of false thing. But we're not asking if they're the same, we're asking if they're not the same. And so you have to kind of do like a double negative kind of thing going on here. So you have to be very careful, again, evaluating and building these statements. Let's see, where are we? Relational operators. All right, so let's use this Boolean expression in some kind of if statement. So I'm going to have if, I'm going to use the game over here again. I'm going to use number. If number equals 3, now I'm just going to hit return here. It indents it for me, which is nice. It knows that there should be a statement after the if. So system.out.println, it is 3. So I finished off the statement here, right? It's a full statement with a semicolon. I hit return. It knows that the next thing that should really be here is an else. And I'm going to really copy and paste this part. It is not 3. All right, so I'm going to run this. So stored in number is 3. Oops, my spacing here is bad. I'm sorry. It's nice to have a little space around there. If number is equal to 3, are they the same? Number is 3. Is 3 equal to 3? It is true. The true statement here is executed. It executes it. It prints out it is 3. And then it skips over down here. I'm going to actually print out just some kind of random line afterwards just to show that the execution keeps going here. And we need a little more space to see it. Okay, so it is 3, and then it prints out done, right? Notice this one is not indented. It's not part of the if statement. This is the full if statement here. So that's a single statement there. And then this is just another statement in the program. If I could say, oops, if number is less than 4, since number is 3, 3 is less than 4 is true, it still prints out, well, now my statement's wrong because it's, we don't really know that it's 3, but okay. And I'm going to print out is number greater than 4. In this case, expression is false, and so it skips over this one, finds the else, and prints this out, and then continues on with the program and prints this out. All right, so the false Boolean expression means skip this, go to this. Not too bad, really. Okay, there's a lot of variations with if, which is where it gets a little complicated. The else part is optional. I'm going to delete that for now. So in this case, if number less than 4, which is true, it does the true part. That's good. If this expression is false, then it skips over the true part, and there is no else, so it just goes on to the next statement, right? It's basically saying we only want to do something if something is true, otherwise just continue with the program. We can, let me actually bring that back. Okay. We can replace a single statement in either of these parts with a statement block. And I can put multiple actions in the true part, for example. All right. And when I run it, both those are going to run, except I didn't do something right. I forgot my semicolon. And also it won't actually execute. So here, number less than 4, that's true. It executes this entire statement block and then skips over the rest of it. Now, a common mistake is to, let's see, oops, got rid of that, got rid of that. Let's see, let's make it so it does not execute. And maybe you're thinking like, I don't know, I see people throwing semicolons, right? You just, I warn you to be careful with semicolons, so you start adding them in a lot of places. Here printed out, it is 3, it was true. Now is number greater than 4? Number is 3. This is false. It wants to skip over the true part. Wait, number greater than 4, false. Okay, here's the, well, here's the thing. I put a semicolon there. That acts as an independent true statement. It's like an empty statement. It doesn't do anything. And so you know, but this semicolon is a complete statement. And when this is true, it executes this. And then it goes on to the next thing. The next thing is sort of this weird empty code block. It doesn't belong to anything. It's just like a randomly made code block, but it executes what's inside there and prints everything out. If this is greater than, it skips over the true part. There is no else part. And so it goes on to the next statement that's available, which is this, and it still does that. So anyway, that extra semicolon basically makes it so that this block happens for either true or false things. Now, when it's laid out like this, it's a little easier to see that something is weird. But if you just sort of throw a semicolon in there, and you'd have to kind of fight Eclipse in the sense of it will not want to indent things the same way, and you're going to force it probably. So if you find yourself forcing, you know, statements to be indented or something like that, go back and look and make sure you haven't done something like this where you've added a logical error. So that's kind of a mistake. And then another thing you can do that's sort of interesting is, let's say we have a bunch of, let's see, if number equals 5, I'm going to say, let's grab that print line. It is 5. I might have another statement if number less than 5 it is less than 5. So here I'm just making a bunch of if statements in a row. Greater than 5. Okay, so I'll get rid of this stuff here and then the done. If I run this, it says it is less than 5 because the number is 3. Is number equal to 5? No, it is not. It skips over the true part. There is no else. It goes to the next if statement. Is number less than 5? That's true. It prints out it's less than 5. It goes to the next statement. If number greater than 5, it's not, so it skips that and then it prints done. Now, that works, but there's a relationship between all these things. We're trying to check sort of all the possibilities. Is it equal to this thing? Is it on one side of the number line, greater than? Is it less than? And so these statements are actually connected to each other. And so another form is to make them all be part of a multiple if-then-else chain. So in this case, how does it check? It says if number is equal to 5, that's not true. So it does the else part. For the else part, it asks, is the number less than 5? And that's true. Since it's true, it skips over the else for that if and just goes to done. It has the same result as before, but notice it kind of quit when it found the case it was interested in here, right? So if I were to say number equals 5, it's 5. So number equals 5 is true. It prints this out, and it skips the else statement for that and goes right to the done. In other words, it sort of finishes up a little bit faster. It also prevents you from making certain kinds of errors. So like if I change the 5 to a 3 and then did this, what is the importance of this case here? So we know it's not, if it gets to this case, we know it's not equal to 3. We know it's not less than 3. The only thing that remains is that it has to be greater than 3. So do we even have to check it at this point? No, we don't. So for example here, I can get rid of that final if check and just say, okay, it's not 3, it's not less than 3. It must be greater than 3. And so we're going to print out greater than 3, 3, 3, right? In other words, I sort of reduced the possibility of making error, some sort of typo error when I change things, because there's only, there's this case, and then there's the everything else case that I'm using right here. Okay, so these get a little complicated, and notice, like, well, let me say one other thing about this. This is really the same as this, right? So there's an if statement with a true part, there's an else, and this is the statement that happens when it's false. And the thing is, if we keep doing this kind of thing more and more, we're going to keep indenting each time we add another layer of if statements, and pretty soon it scrolls off the screen. So people kind of come up with this convention that if you're just sort of checking this chain of conditions, it's sort of nice to just indent them like this, where you can kind of read it down, you know, is it this, is it this, is it this? But keep in mind that this is just formatting for us to help it understand. It's not a new kind of statement that has all these multiple ifs and else. This statement is the statement that executes if that condition is false. All right, so we'll practice this quite a bit, and you'll get used to it, but you have to read these very carefully. It's a whole different kind of style. And we'll read about this in the runestone. All right, thanks, bye.